Chapter 9.1. We're in the very last chapter. What we're going to be looking at in Chapter 9 is correlation and regression, and the first thing that we're going to look at is scatter diagrams and linear correlation. So in this example that we have the x variable, which represents the length of a fish, and we have the y variable, which gives us the weight of the fish. And we have this table, so we have all of these x values. So this means the fish is 20 inches in length, 24 inches in length, and so forth. And then our y value tells us its weight. So this fish that is 20 inches in length weighs 2 pounds. This fish that is 24 inches in length weighs 4 pounds. So each one of these gives us an ordered pair. So this first x and y is the ordered pair 22, and so I've listed all of the ordered pairs. Then what we have done is we've taken those 5 ordered pairs and we've placed them on a scatter diagram. Now, we have our x-axis, which is our length of the fish, and then we have our y-axis, which is the weight of the fish. So the ordered pair 22, they went over 20 up 2, and they went over 24 up 4, over 36 and up 12, and so forth. So we have our 5 fish graphed on this scatter diagram. Now, what we are looking for in a scatter diagram is to see if there is any linear correlation, and a linear means it makes a line. So if you will notice that if you were to connect these dots, although they wouldn't be on a perfect line, it does appear to have linear correlation in that it would create a line. So we would say that these ordered pairs have linear correlation. Now, one way to see if 2 points have linear correlation is to create a scatter diagram, which we just looked at. And here is the different types of linear correlation that you can get. You can get a positive correlation, and when it is positive, that means that your line would go upward. Because if you'll notice in both of these examples, the line would go upward, so it's said to have a positive correlation. Now, in a positive correlation, you can have what we call perfect positive, strong positive, moderate positive, and this, I wrote moderate again, but this is supposed to be weak positive. Sorry about that. So perfect, strong, moderate, or weak positive. Now, when you have a perfect positive correlation, it means every one of these points would fall exactly on the line. Here we have a moderate, and it says the points are somewhat linear, meaning it does appear to have some correlation, just not as much of a correlation as a perfect positive. Then something in between this you would call strong, and then one where they are not quite as much of a line as this we would call weak. Now, one thing that you need to notice is that when we have positive correlation, both values, meaning the x value and the y value, are both increasing. So as x increases, y increases as well. So if you would look at our scatter diagram, it is going upward, so that tells us it has a positive correlation. Now, if I were to get a ruler and draw a line, they would not all fall exactly on the line. Therefore, we cannot call this a perfect positive. Correlation in this one, I would call strong positive. Okay? Now, that's when you have a positive correlation. On the next page of notes, you will see that the correlation can also be negative. And again, I wrote moderate twice. Don't know what I was thinking. Sorry about that. This would be weak. So, your correlation can also be perfect negative, strong negative, moderate negative, or weak negative. And that makes it negative is that the line would slope downward. Now, please pay close attention to this. As the x value increases, so as you move to the right, your x value would increase, the other decreases, the y value decreases. So as x gets bigger, y gets smaller. So be sure and make note of that. Again, perfect, all the points are on the line. Strong, they're all almost on the line. Moderate, not so much. Weak, a little bit less than that. And then we can also have where we have no linear correlation. Now, both of these have no linear correlation. This one appears to have some sort of a correlation. I think it looks like birds in flight. It's just not a linear because it does not make a straight line. So those are examples of no linear correlation. Now, that's how you tell from a scatter diagram if there's linear correlation. There's also a value we can calculate that will tell us if there is any linear correlation. This is called the sample correlation coefficient, also known as Pearson product moment correlation coefficient, which is quite a mouthful, otherwise known as R. Just know that when it asks for this, it wants you to calculate R. Now, what R does is it takes our two variables, our x variable and our y variable, and it calculates it into a single value that tells us how strong that linear correlation is. Now, here are the properties you need to be aware of. First off, your x and your y, our x was length and our y was weight. Once we calculate it into R, it's unitless. Okay, it's just a number. This number will always be between -1 and 1. So if you calculate R and you get 245.11, you've done something incorrect. So be careful of that. It will always be a number between -1 and 1. If you get R equals 1, if you'll notice I have a number line over here. If you get R equals 1, positive 1, if it's positive 1, you have a positive correlation. If it's exactly 1, you have a perfect positive. Okay, so this would be perfect positive. If we get R equals negative, it means we have a negative correlation, and that correlation would be a perfect negative. 0 means no correlation whatsoever. Okay, so that would be at 0. So in between, then you would look at dividing this into thirds. So here would be strong positive, here would be moderate positive, here would be weak. I'm sorry, not positive. Here would be strong negative, moderate negative, weak negative. Weak positive, moderate positive, strong positive. So that's how you use the value for R. Now, at the bottom of this page of notes, you'll see the formula for calculating R. Now, it looks a whole lot worse than it is. I'm going to show you where to get the values. I'm going to show you how to enter it into the calculator so you only have to push equals once. Now, the things that you need to make note of is this is summation, so we have lots of summation. Summation of xy, summation of x, summation of y, summation of x squared, summation of y squared. And the other thing I want to point out is notice in the denominator, we have two separate square roots. A lot of times I'll have students that try to put it all under one square root. But this information is under the first square root. You come out from under that, times, and then this information is under the second square root. So the first thing that we're going to look at is how to find all of those summation values. On your next page of notes, you're going to see a table. And this table is extremely helpful in calculating R. Now, I've already filled in some of the numbers, but I want to show you where those numbers came from, okay? Here are the x values. This is 20 inches, 24, 36, 41, 46. That was given from the sample on the first page of notes. Here are our y values, 2, 4, 12, 15, and 20, okay? Now, I have created a row that is x squared. So what I've done is gone to my calculator and put in 20 x squared, and I get 400, or 24 times 24, 576. And so 36 squared is 1296, 41 squared is 1681, 46 to the second power is 2116. And then this row is y squared. So I'm going to take 2 squared, which is 4, 4 squared is 16, 12 squared is 144, 15 squared is 225, and 20 squared is 400. And then the last one, xy, means to take x times y. So I took 20 times 2 is 40, 24 times 4 is 96, 36 times 12 is 432, 41 times 15 is 615, and 46 times 20 is 920. So that's how you find all of those values. Now, oops, sorry about that, knocked my computer. Okay, notice this last column. This is your summation column, and this will be the numbers that we will use. So the summation of x tells me to add 20 plus 24 plus 36 plus 41 plus 46. And that adds up to 167. And then we're going to add 2 plus 4 plus 12 plus 15 plus 20, and you get 53. And then when you add all of your x squareds, you get 69. And then all of your y squareds, you get 789. And then the last one, you add all of those up and you get 2103. Now, these summation values are what we're going to use in the formula for R as well as N. N is the number of ordered pairs. We had 1, 2, 3, 4, 5. So N equals 5 because we have 5 ordered pairs. So what I'm going to do now is I'm going to put my summation values into my R. So I'm using the formula that was on the previous page of notes. So you need to follow that. So in the numerator on the top it says to take N, and we just talked about that that is 5, times the summation of xy is 2103, minus the summation of x, 167. Now I'm going to use the multiplication symbol and not parentheses because the parentheses are critical when you put it into your calculator, so I don't want you to get confused on where to put those. So then we have the summation of y, which is 53, and that is my numerator. So then my denominator, I'm going to have a square root, and it's going to be n, which is 5, times the summation of x squared, which is 69, minus the summation of x, 167 squared, which means to take 167 to the second power. And that's one radical. And I'm going to multiply that times the second radical, which is n, which is 5, times the summation of y squared, which is 789, minus the summation of y, which is 53 to the second power. Now, remember when you do this calculation, you were going to calculate a number that is between -1 and 1. Okay, so it's critical that you put it into your calculator correctly. So when we do, we're going to put an open parenthesis here and a closed parenthesis here. Nobody has any problem with that. But the denominator is where you have to be careful. You will put a parenthesis before that square root. Then you will enclose that is under the radical in parentheses, as well as this one. And then you will close the denominator in its parentheses. So I'm going to try to get the calculator up there to where you can see it and show you how to enter this. So you're going to do open parentheses, 5 times 2103 minus 167 times 53, close parentheses. That's your numerator. Then we're going to push the divided by sign. Then this parenthesis is critical. Open parentheses, and then square root is second x squared. Then my radical automatically opens a parentheses. If yours does not, you need to open the parentheses. Then you're going to do 5 times 69 minus 167 squared, so I'm going to push the x squared button, and then I close that radical, and then I push times, then I open a second radical, and we have 5 times 789 minus 53 to the second power, close the second radical, close the denominator, then push equals. And we get 0.996207885. Now, What you do not want to do is round that to 2 decimal places. If you round it to 2 decimal places, you are going to get the whole number 1, which would mean we have a perfect positive. We do not have a perfect positive, so for this particular problem, it makes sense to round that to 0.996. And of course, 0.996 is very near positive 1, so this confirms that we have a strong positive correlation. That is 9.1.